Now let us discuss about how to generate a Fibonacci series by using recursion. Recursion is basically a process in which a function calls itself again and again is called a recursion, and also the well-defined recursion function is which consists of a base criteria and also a mechanism which will bring the function, will bring the particular variable closer to the base criteria. So that's called a well-defined recursive function. Okay, so now Fibonacci's sequence we might have learned even in our earlier classes. So Fibonacci numbers are given like 0, 1, then 1, 2, 3, 5, 8, 13, 21 goes on like that. And how it is generated? By adding the preceding two numbers. So 0 plus 1 will be 1, 1 plus 1 will be 2, 2 plus 1 will be 3, 3 plus 2 will be 5, and 5 plus 3 will be 8, and so on. So that's a Fibonacci sequence. So we are going to write a program. We are going to discuss an algorithm to find out the nth Fibonacci number or nth Fibonacci value in the given sequence. Okay, fine. So in our example, we consider this to be the first one to be at 0th position. So 0, 1, 2, 3, 4, 5, like that we'll address it. Okay. And yes, by definition, we can say that when n is equal to 0 or n is equal to 1, n is equal to 0 or n is equal to 1, then the Fibonacci of 0 is equal to 0 and the Fibonacci of 1 will be equal to 1. So that's the basic definition, because we are starting with the index with 0. So n is equal to 0 means Fibonacci will be 0, and n equal to 1 also the Fibonacci at one position is going to be 1. What if the number is greater than 1? So when number is greater than 1, we just use this simple definition where the nth Fibonacci number is computed by adding fn minus 2 plus fn minus 1. fn minus 2 plus fn minus 1. For an example, let's say I want to compute the third Fibonacci number. So as I told you, I'm just labeling it as 0, 1, 2, 3. So 3 should be what? It should be 2 we should get. So n minus 2. So this is now n number. 3 is our n. N minus 2 will be 1 plus this is 3 will be equal to 2. So by using this concept, we can develop a Fibonacci sequence. Now, talking about the base values, whenever we have a recursive function, what is important for us? Our important thing is the base criteria. Base criteria is needed, isn't it? So how do we get a base criteria from this? The base criteria is this first condition will be the base criteria. If n is equal to 1 or n is equal to 0, then we say that if n is equal to n, so this is considered to be the base criteria. Okay, so any given number, we'll try to bring it down to 0 and 1 so that we can continue our work. Okay, so that's a base value. 0 and 1 are the base values for us. Okay. Now let us discuss an algorithm to find nth term, nth term f1 of the Fibonacci series. So we use an algorithm called Fibo. It's basically a function, and it's a function of or depends on a variable called fi, b, and n. Okay, so we can simply say n is an input, and fib is going to be the output. Okay, now, so if first we define our base criteria, if n is equal to 0 or n is equal to 1, then we set the fib is equal to 1 as per the first definition. As per the first definition, and this is no, this is called a base criteria also. Base criteria. What if the number is greater than 1? So when number is greater than 1, the number is greater than 1, recursively we will call the Fibo function by passing n minus 2 first, n minus 2, and one value FIBA, FIBA. So by passing this, we will be able to recursively we can call the function, and also by passing another value, we will by also sending n minus 1, we will call the Fibo recursively. So by doing this recursively, now we will be able to got it. What is FIBA? FIBA is the output of the Fibo function for an argument n minus 2, whereas FIBA is an output variable for a Fibo function when n minus 1 is applied. N minus 1 is supplied here. Okay, so then what we'll do now, we got two Fibonacci numbers, that is n minus 2 Fibonacci number we got, and also we got a n minus 1 Fibonacci number. Now all that what we have to do is we have to add fib A and fib B, that will give us the required Fibonacci number or nth Fibonacci number. Okay, so that's the basic algorithm. What do we do? First we send the n, and depends on the n value, the base criteria may be chosen, or it may choose any of the. First it will choose this function. After executing this function will be selected. Okay, so that's how basically the work is done. Now coming to the implementation of Fibonacci number. Okay, so here this is a main program where it uses local integers like n, f, and I, and it asks the user to type a value by prompting on the screen what is the n value. Then whatever is given, that is taken into the n variable. Then it starts with fib series for n is equal to. So this n, whatever you entered, will come here, and it goes to the next number, and n will be printed here. Whatever the n value we are given here for n is equal to 2 or 3, something like that, it will be given. Then next, what we need to do, we need to generate an index. We need to generate an index here. So in order to generate an index, we use one for loop here, which generates the values of I, that is less than or equal to n, and every time it's going to be incremented. And now what we do, we call a Fibo function. I'll discuss shortly with you what is the Fibo function. So the Fibo function is called with the value I. It passed with the value I. Then what it happened, it's going to return a f as a Fibonacci value, one value, because we are considered about the nth series. Okay, so one Fibonacci value will be given. That will be the nth Fibonacci number. That will be the nth Fibonacci number. Okay, so now let us discuss about the function that is related to it. Function related to this one. Yeah, this is the Fibo function. Fibo function. which we are going to use it to generate or to find the nth Fibonacci number by passing the n value. N value is basically an index. It's basically an index here. Okay. Now you see that whatever the algorithm we earlier discussed, so the same is now it is translated into a C program here. Okay. So what is this things from here? It is a base criteria. Base criteria. What is the base criteria? Where number is equal to 0 or number is equal to 1, then Fibonacci series will be 1 only. Fibonacci series will be 1 over here. Okay. So that's how basically it functions. Then if basic criteria is satisfied, it returns a Fibonacci value FIB. FIB. Okay, if not, if the base criteria is not satisfied, then what first it will do? It will try to call the Fibo function by passing n minus 2 values, n minus 2 value number. So n minus 2, again, if the base criteria is going to be satisfied, it will do it. Otherwise, again, the value will be further reduced and it will be passed. So that's how basically the recursion works. After completing this, if it returns value, it's going to be FIBA. Then depends on the stack condition, the present number will be reduced by 1, and this number it's going to be passed here into FIBO, and that will return a value FIBB. So again, it depends on the condition whether it's going to return the value or not. Okay, next what happened? Finally, what we'll do, we add these two values, FibA and FibBB. These values are added to get the required Fibonacci number. To get the required Fibonacci number, that's the nth series of the Fibonacci number. Okay. So now let us consider one simple example here for understanding this concept, since the recursive functions are used here. Let us assume that we are calling the Fibonacci series to find out the number in position 3. As I already told you, what are the things here? Fibonacci series is 0, 1, 1, 2. So we are starting with an index 1, 0, 1, 2, and 3. So what number we are supposed to get? We are supposed to get the number 2. We're supposed to get the number 2 here. Okay. So now what will happen? 3 you are sending it. So there is a first one, there is one function call. So what is the function called here? Fibo is called with the number 3. Fibo is called with the number 3. Okay, what is expected here? That let us see that. Let us see what is expected here. Okay, so Fibo 3. So Fibo 3, when it's passed here, the condition is going to be checked. This condition is not going to be satisfied. If this condition is not satisfied, next it will come to this position. It will come to this position. So when it comes to here, now the Fibo what you are passing here, when it's called, you're supposed to return. This is a main function call. So what we are supposed to return is a fib number. The fib is going to be returned from this. From this, fib is going to be returned. But now when it comes to this place, there is one more function call here. This function call is going to be recorded here. What is the function call here now? That is Fibo of 3 minus 2. That is 1. 3 minus 2, 1. And when it returns a value, that will be FibA. That will be FibA. Okay. So now what will happen now? Fib 1, this will go here. So when it comes to 1, a condition, base condition is satisfied. And now it's going to return a fib from this. This fib, it's going to be caught by this FibA. So, okay. So now what will be the FibA here? It will be 1. It will be 1. Since this condition, this function call has returned a value, so this function we can neglect it. But value FibA will be equal to 1 only. Okay. The next one will come to it. So value is returned. So once the value is returned, next where it will come, next it will come to the next statement. What is next statement? Now, since here this is 1 is no more valid, now the current n value will be 3 only. For the next iteration, n will be equal to 3. So now what will happen here? The Fibo will be called by passing number minus 1. So which is nothing but Fibo of 3 minus 1, that's going to be 2. That's going to be 2. And as it falls the function, it returns a value fib_bb. It returns a value fib_bb. Okay, so we will keep it in the record. Okay, so fib_bb function is called for 2. So when again now the value is getting into this number. Okay, it's no more 3. Now it comes with the 2. Now when it comes with the 2, again the base conditions are not satisfied. So the base condition is not satisfied. So again it will invoke this function here, Fibo. So what is the value? 2 minus 2. So it will invoke a function now, Fibo of 0. Fibo of 0, because 2 minus 2. Currently the n value is 2. So 2 minus 2, n will be 0. And this will get a value again fib_a. Fib_a. So now, as you know that fib_0 is going to be called now, isn't it? When fib_0 is going to be called, what will happen? When fib_0 is going to be called, base condition is satisfied. If the base condition is satisfied, so this fib_a will be equal to 0. Fib_a will be equal to 0. Okay. Yes, that is done. Next, immediately, so this value is returned. This value is returned. Now, no more fib_0. No more fib_0. Now, what is the next n value that is there in the queue? That is 2. Okay. So, next, when it comes to this position, we call Fibo by reducing it by 1. Isn't it? So, 2 minus 1. Now, we are going to make a call for the Fibo function with the value 1. So what does it return? It returns the Fibo you are calling. So this is supposed to return fib_b value. So what is the fib_b value? That's going to be 1. That's going to be 1 here. Okay. So now after execution, we have returned it, here and here we have returned. Okay. Next, what we have to do? Next, we have to return a value. So when you return a value, because after that it's going to come and execute this part. It's going to come and execute this part. Before that, it remembers that there are few function calls were made, and for those function calls, the values are not returned. And also there are some more statement that FIB is equal to FIBA plus FIBB as well. So what do we need to do now? Now it's going to return a value in a sequence. So this value is already written. No, this value is already written. So again, it will start from this new one. Okay. So what is the new one here? Yes, the fib_1 will be coming from here. And the next return will give this value. So these two will be added together, and this will give the value 1. This will give the value 1. Okay. Next, what else? What else is left? What else is left? FIBB and FIBA. This FIBA already is there. So now here, FIBB, it's not newly computed, but still it is having a value. So what it will do now, this fib_1, same fib_1 will be used here. So this will become fib_1, and here there is fib_a. So now these two will get added. These two will get added, and that will give value 2. That will give the value 2. Okay. So finally, the last one is what? The last one is fib_a and fib_b. Okay. So in this condition now, what will happen? So by adding fib_b and fib_a together, it gives the value 2. Then this value will be returned to the main program. It will return to the main program. So from the main program, we might have given a call. Okay, from the main program, we might have given a call for Fibo of 3. Fibo of 3. Now, this will get the value, no? So that need to be stored here. So let's say F. Then the F value will be given as 2. Okay, if you look at the program, you can understand this. Okay, now let us see this program in simulation. So, yeah, so this is the program here. So you can see the program. That's a main program here. And in the main program, what else is there? In a main program, the local variables are there, and also there's a for loop to generate the index values. And next, what do we have? Next, we have a Fibo function over there. Okay. So now I'm going to debug this program. As I debug this program, you'll understand. So what is the n value? What is the n value? So I'm giving the n, I'm going to give the n value as 3. N value as 3. So now when n value is given as 3, I set my breakpoint here. So I know wherever I required, no, and I'm just printing the values of I and f values. So here I is equal to 0 now. So 0 means the key number, and that is going to be 0. And the next 1 value, 1 also it will satisfy the base condition. Satisfy the base condition, it returns a value immediately. So then we no problem. It's going on. Then the n value will become 2 now. With the n value will become 2 with the help of this I number. Okay, so I index, it's 2 now. So now running this into the Fibo function, now we see that n is equal to 2. How about the base criteria? The base criteria will not be satisfied. The base criteria is not satisfied. What will happen now? This number will be reduced. So reduced by what? 2. So already what is the num? It's 2. So now it becomes 0. Now it becomes 0. 0 means the base condition is satisfied. Base condition is satisfied. As the base condition is satisfied, it will immediately return the value. So what we will get immediately? We'll get a fib A we will get. So what is the fib A we got? It's a 0. It's a 0 here. And next what? It will, now since it is returned here, it is returned here. So num will not be 0, num will be 2 only. So 2 minus 1. 2 minus 1. 2 minus 1 is what? It's 1 only. So now this will be entered into this num function. So it will be into the Fibo function through num. So now what will be the number now? Number will be 1. Number will be 1 here. So number is 1. Well, it will satisfy the base criteria. So as it satisfies the base criteria, it returns the value. So what you got now? We got fib BA and also fib BB we got. Okay. So only one thing we have to work it out, because for 2 already we worked out, and yeah, for both we got the value. Fib A and fib BB we got the value. So next thing is to get these values added. Fib A and fib B, get it added here. So as it gets added here, so what will happen? Now it will compute fib. So as it computes the fib, we can return the fib value to the main program. Now this will give the value fib1. That is the Fibonacci series at 2 is 1. Next is Fibonacci series at 3. Fibonacci series at 3, what will happen now? I is incremented. I is equal to 3 now. And as I is equal to 3, then what will happen now? Fibonacci is called. So 3, it's not going to satisfy the base condition. So it goes to the recursion. As it get into the recursion, 3 minus 2 becomes 1. So that satisfies the base condition. So we will get 1 from there, isn't it? Then what will happen? So next what we'll do, we'll go for the next Fibonacci function. So now here, what are the values? Since it is returned here, it will be 3. 3 minus 1, 2. So again, what will happen now? It will come to the num, and after it come to the num, again it will check it out whether it is satisfied. So actually, this is not going to satisfy because 3 minus 1 is 2, so it comes to this place. And now what will happen? The num will be reduced by 2, so it will be 0. So Fibo of 0 will be given here. Fibo of 0 will be given. So that satisfies the criteria. Got it? So like this, as we continue to see that, so it will keep reducing the number and it will try to reach us the base criteria. And as it reaches the base criteria, finally it will get the value. So on this, as these two values gets added, then that will be the final fib number. So that is a Fibonacci series of nth order. Fibonacci series of nth order. So that is what? That is actually 2. It's printed on the screen now. Okay. Thank you.